Hey programmers, Alvin here. Right now I want to go over a JavaScript solution for this bottom right value problem. So I'll go ahead and implement the strategy we spoke about in the approach video, which we said was all about making a breadth first traversal. So I'll start by initializing my queue. So I'll say const queue, and I'll go ahead and make it just an array filled with the root. Nice. Now one thing we have to maybe consider here is, can we have an empty tree? It looks like given the assumptions in the problem, we don't need to check if the initial tree is empty. And so we could just jump right in and initialize our queue with the root. Then what I'll do is I'll write my classic traversal code. So I want to keep iterating while my queue has elements, right? So while queue length is greater than 0, of course. And for a single iteration of the queue, in this algorithm, what I'll do is I'll remove the front of my queue. So I'll say queue.shift. That'll give me the current element. And then from there, I want to consider this element's children for now, right? So I'm going to check, all right, if my children exist, I'll check if current, we'll say .left is not equal to null, And likewise for the right-hand side. Well, in the case that current left is not null, then I'll go ahead and push current left into the queue. So queue.push current.left. And just symmetric for the right-hand side, just like this. Nice. When we spoke about the approach for this problem, we said that if we solve this breadth first, we want to make sure that we push or we add the left to our queue first, and then we add the right. That means the rightmost node will be the last thing to leave the queue. Because remember, queue is first in, first out. So left things leave first, right things leave later. Nice. And what I need to establish is, basically on the last iteration of this loop, my current would be exactly what it needs to be, right? It'd be the bottom rightmost value. There are a few ways you can probably establish that piece of logic. One thing you can do is maybe just have this variable on the outside. So I'll say let current over here, maybe start as null, and then I'll just reassign it over here. That means on the last iteration, once my queue becomes empty, I will still have access to the current variable. Because let and const variables are going to have block scopes. If I declare like the let on the inside, it won't be accessible over here. If I declare it on the outside, it will be accessible. Cool. So over here, we'll just return. Be sure to return current.value, right? If you just return current, that's returning the instance of node, but you really want the inner value, right? So current.val would be the move here. Before we run it, what I want to definitely be sure to do is only declare the lets on the outside, right? So I have this variable let current outside the while loop, so that's also available after the while loop finishes. So let's give that a run. See what we get. Should return the bottom rightmost values. Nice, and there we have it. Possibly another way you can go about returning what's on the last iteration is, let's say you really want to declare this on the inside. I could imagine that after you push any children, if they exist, let's say you push nothing, then occasionally that would lead to your queue being empty. So if you wanted to, I guess you can also say over here, I don't know, if queue.length is 0, then just go ahead and return current.val. Then you wouldn't really need a late return over here. This would probably also work. Give that a go. But I think any way that you kind of express that pattern, overall I feel like the breadth first traversal is probably the most reasonable way to solve this one. So give this problem a shot on your own. If you had any issues, I recommend you still try to code it up on your own. Pretty core patterns here, and I'll catch you in the next video.